Yeah. Welcome to Wednesday. This one, particular one, anybody tried it yet? At least wrote it down probably. Let's see, a triangle kind of looks like this, I think. I think this is what triangles look like.
I disagree.
Totally disagree. I know, but you disagree with physics too, so.
Well,
Got him. So you are
there's a
right.
little curve at the one of the corners.
Oh, yeah, they don't connect.
Oh, no.
Yeah, the angle C doesn't actually connect. It's not an angle. And angle B is like a little nose thing.
Okay, now draw on the scale. This one, let's see, B is 6, and let's see, A is 2. That's cool. And just trying to find angle B.
Whoa, 6.
Yeah, I don't. Oh, wait. Dude. Really makes me
Bro, it looks like a
Wait,
spoon.
Yeah, you're right.
That's
The
crazy.
spoon from the Matrix. Though.
Right, yeah.
That's what we're all talking about. We say
A spoon from the Matrix.
Not like a ladle.
You know, it's the Matrix.
Good like that. I think everybody got to that point. Hopefully got to that point.
Yeah.
We go with it here. So sine of A is 30 degrees. Let's put in the values here. That's 2 here. That is, ooh, this is sine of B, right? And then 6 is on the bottom here. Okay. Multiply by 6 both ways. Or that way. So let's see. Let's reduce here. That okay? 6 is going to be here. It's going to reduce with the 2. Everybody okay with 3 sine 30 degrees is equal to sine B? Awesome. Okay. So yes, got to get your calculators out.
Whoa, I actually have it.
Thank you. It's a miracle.
Sine 30 degrees. Sine of 30 degrees. Got him.
Well, sine of
Grant.
30 degrees is 1/2.
Yeah, just 3 times 1/2, right?
3 times 1/2, okay.
Yeah, it's calculator operation.
Which is what, 1.5?
Yeah.
Okay, and then it's equal to sine B. So therefore, let's see, it's going to be sine inverse of 1.5 gives you B. Correcto?
Uh-oh.
I got no.
No.
Oh, because sine can't be
Yeah,
greater
it's
than 1.
domain error.
Oh, wow. Yes. Okay. Domain error. That guy is greater than 1. So the question is, what happened?
Clearly, B just doesn't exist.
The triangle doesn't exist.
Yes, that's very true. How come is?
So Grant was right when
The
he
sarcasm is
Wow.
right.
So he broke physics.
Yeah.
Whoa.
It really is the end times of grants.
Cool. I guess we can just wait. Is it because it like doesn't connect?
Oh, okay.
The angles
Talk
probably
to
don't add
some.
up to 180.
Angles shoot up to 180 if it's a triangle.
But it
You just
isn't.
said it.
Yeah.
So, getting mixed messages.
What does not connect? You know what? Maybe another thing like this. Let's see. If I were to drop this straight down like this, like a little altitude, right there. Question is, what would H have to be?
Yeah, I agree.
So
Very frustrating.
this would be what? This would be sine of 30 is equal to H over 6. Hey, got the same thing that happened here. Multiply by 6. What is actually 6 sine 30?
Indeed.
3 is good?
Yeah.
Yeah, half. Sine of
That is my calculator.
6 halves.
6 halves are 3. Okay, talk to me some more. Whoever's awake.
So none of us.
Oh, I see.
Oh,
It's yeah, longer than the hypotenuse.
Yeah.
Say again, say again.
If it. Am I right there, or am I totally wrong?
Getting there, go ahead, good. But
Because-
speak your mind, go for
Because
it.
3 is way bigger than 2, so therefore it
I agree.
I think so. It's that little 3 here. This guy is equal to 3.
As Socrates once said, therefore.
I have a 2. So really, in a sense, what we would think about is the minimum. Minimum, this would be 3, right? To get to the other side. If this is 2, forget it. If it was bigger than 3, we can probably have a triangle. So let's go with it. This is called the 7.2, the ambiguous case for sine. So we know.
Ambiguity in math.
So does that mean that we can be ambiguous?
That's like the antithesis to what we're trying to do.
Just in this piece here.
We can just
Yay.
label everything with X and then just be like, it stands for the answer. You have to figure it out though. Like, I'm not gonna.
Find that too.
It's like the kid that had this on the test and it says X right here. It says find X, right?
Yeah, find that.
There it is, right?
Right there.
The reverse cardinal guy.
It's the easiest word search ever. There's only one letter.
Let's see. I think we had something like this in geometry, though. Do you guys remember for geometry days? The geometry days.
I just said no answer.
If the sides of a triangle were 13, 17, and 2, is that possible? Is that possible to form a triangle that has sides 13, 17, and 2?
I remember that being like important.
No,
Yeah,
because
something
the
important.
sum of two sides have to equal like the bigger side.
Oh, yeah.
Hypotenuse.
Yeah.
Oh, yes, because all triangles are right.
Let's see. The sum of 2 sides has to be greater than, right, the third side. So any of these add up, that would not be able to. Uh-huh. But yeah, that 17 is too big, right? That 17 goes like this. So if you have the 13, it goes back this way, and then you have 2. So question, will those guys ever meet? No, not possible. We're gonna not connect. It's too shy of making a straight line. It'd have to be higher than 2 to even form a triangle. Are we good? So that's the whole problem, is that when you're given just random numbers, it just may not work out. So let's go with it here. So we're gonna put this ambiguous case to the test here. So this one is not possible. Not possible. We can even say no solution. And in fact, I think the back of the book just says no solution whenever you're solving for this. We'll get into the point of how many triangles are there, first of all, and then we can solve for them. So let's go with it. Kind of slowly here as we go through this here. So let's go through this case again.
Yeah, so how does that triangle exist? Like,
It does not.
Yeah,
like how would you correctly draw it? Because it looks like a triangle here.
Sure.
well, yeah, anything looks like.
So we're gonna correct drawing on the next slide in just a second.
It looks like a triangle.
When you don't label everything.
Triangle.
It's like
Let's jam. So let's see, where does this occur? So why is it even an ambiguous case in the first place? Is we have an angle, one angle, so we can't solve for the other 2. That's a little problem. The other thing is we only know one angle, its opposite side, and then we know the other side. So that's when it occurs. So you sort of, when you look at your homework here, it's gonna be like this. It's gonna be this side, which is little a, connected to big A. There's your angle on opposite side, and then you know another side. That's our little problem. And it only occurs right there. So 7.1 was the easy stuff, law of sines. 7.2 says, what happens in this case? We're good? Let's jam. So yes, there are way different cases. So if I were to draw the previous problem, the way it should be, here's my 30 degrees, we're good? And this is probably even too short here, too long. But to illustrate the point is, we need h is equal to 6 times 1/2. H is equal to 3, we good there? So to get to the other side, I need at least a 3. That's the bare minimum. It'll form a right triangle. This guy is 2, not possible. We're good? So let's jam with the cases here. So first case, this guy's less than 90 degrees. And then we do have to figure what h is each time. In this case, it's gonna be 3. And here's the other case, that a is less than h. So if you want to write this stuff down just to,
So you're saying like for everything that's the case? And this, like, are you saying that that's the universal case or just for this problem that's the case?
just for this problem, and it's all based upon the connection between these two and whether this is a acute triangle or an obtuse triangle. So this is case 1. We're going to go through 6 cases like this. We're good?
Oh.
Yeah, okay, I do label them. Just wanna make sure. Okay. So if the universal rules are right here, here's your little 2 things that sort of are problems. The answer to this guy is no solution. And Georgia, if you want to draw it out, that's the way you draw it out. That it does not make sense. And let's do this. So let's call it case number 1, because then we'll just kind of.
Wait, can you explain again why there's no solution? I was writing it down.
Sure. So got the one side here, however linked this is, and that's why I put a little dot line. So I don't know how long this guy is. I know this guy for sure is 6. Then I know this guy for sure is 2. So it's like this. And I have a 30-degree angle right over here. And here's my little problem. My little 2 can't get to the other side. You can swing it back and forth even, but it's not going to happen. Because my minimum to get to the other side would be 3 in this case.
Oh, I see. I drew it as the line touching the dotted line, so I was like, it looks like
Gotcha.
it works to me. That makes sense.
But make the line longer, yeah, it's not that hard.
So say if
Elongate the 2.
the 2, if that was actually a 5 or something, but it was bent like this direction, but you could tell that it could swing back and touch, and also just by math, you can see that. Will we see problems where it's like at an angle where if you swung it in, it would?
You're getting there. Yep, Grace, awesome. So let's go. This is case 1. Good. Case 2. Let's jam to this one here. This will be case 2. All right, you guys talk to me. What's happening here? So this little line.
So are these rules like the A is less than 90 degrees and A is equal to H? Is this true for every triangle? If A is less than 90 degrees and A is equal to H, there's no solution?
Hold on real quick here. So this one here was a no solution case, right? This guy here, H is equal to A. Now we have a 3 in our hands. So question is, how long does this guy extend? We need a minimum of 3 to get there. Is that right? We have a minimum of 3. In fact, we just got to the end. We good? There it is. We connected the 2 pieces together. And George is right. It is a right triangle at this point. So the question is, do we have a triangle? Absolutely. How many triangles do we have? Just 1. All right.
So,
Okay, talk to me here. Go ahead.
Sorry, for the first case, for any triangle, as long as A is less than 90 degrees and A is less than H, it's
not a solution, or there's no such triangle that exists. That was universal. So you have
A is equal to H, though.
in this case, A is equal to H. We have ourselves case 2, and we have exactly 1 solution. We got ourselves the right triangle.
If A is more than H?
Let's talk about it. Love it when you guys present the next question, the next problem.
That's when the other one goes like that.
Mhm.
And then you draw the line down there too.
Where?
Yes. Grand. Okay, next one. Let's jam. Okay. I got A's equal to 4, so a little bit bigger than this. See, minimum's 3. So hold on, that means that 4 line is actually going to go beyond.
Nice.
It's going to go all the way to here.
Says only like swing. So.
Cool. Adrian says swing somewhere here. Let's see. If we go this way. Oh no, hold on. If we go this way, do we have a triangle that looks like this?
Oh no. Oh no.
Oh, wait, that's still a triangle.
That's not a triangle.
Gasp with that.
So I have a triangle that looks like this.
I don't accept.
Let me guess, we have two
Okay, but if you
triangles.
flip it like that, then it's just,
We could swing this little thing this way. And then we have a triangle that looks like this.
It's like a cat door.
Yeah, I don't accept it.
Yeah,
So,
yeah, two triangles.
2 triangles. Oh, brother.
wait, why is that?
Oh,
Because if you also swung it out the other direction, it'd be bigger. Is it because,
Good, good. Talk to me.
like, is it because if you're just swinging it one way or the other, it makes it smaller or bigger? And so it's like, I don't really know what I'm thinking.
Sure. Okay, let's go back to the drawing here, because we're just kind of doing the drawing. So if A was a 3, I would be right here, true? I'd get right to the other line. Because A is 4, I get to go beyond the line. And now the question is, I have a link that's this long right here.
I
Sorry.
can't see where you're, oh, okay.
What's the area formula for triangles again?
it's,
1/2 base times height.
yeah.
Right, yeah.
And so, Grace, if this is longer here, so then that means if I were to swing it this way, I have this little 4 that's going out this way. There's my 4. Cool. Everybody good there? I can also swing this line this way, and now I have the same exact line. This is still 4, length of 4. But I get myself 2 different triangles that possibly could be formed. Again, it's ambiguous, right? And so the conditions are A is still less than 0. Oh, so A is less than 90 degrees. And I got this little relationship now. So A is stuck between the low end, it's higher than H because it reaches the other side, but it's also less than B. So it's less than that 6 that's on the other side.
So you can't change angle C.
You can change angle C because they're not first conditions here. The only conditions I have is I know angle A.
Okay.
And I know side A and side B. So that means angle C is going to be 2 different variations of whatever triangle I need. Amaya, go ahead.
Why is H less than A? Because it looks like the same thing.
Because when we compute H over here, we get ourselves H being 3 for this particular triangle. So in order to get from angle C straight down to the other side, I just need 3. But in this case, I have 4. So I have enough that I need to get to the other side. And then I'm able to swing this extra unit of 1, right, both ways. I could just swing it to the right as well as to the left, and it forms 2 different triangles for me. Are we good there? Okay. Ooh, leading up with cases here. What is this? Case 3. Okay.
So you don't do anything wrong with it?
We're just gonna know that this is case 3. This is what happens when we have 2 triangles.
And
Maybe we might do something else with it.
So then how many two solutions?
Oh, so when we do the law of sines, guess what? We're gonna have to do like a solution for this one. And then we're gonna have to do a set of solutions for this one. So we'll say, hey, there's 2 different possibilities. Here's your possible values. Once we get to them. So this guy gives us 2 solutions.
which triangle we're talking about? How do they have to?
No.
No, this is the only case that it happens. This is the problem child.
Which
Of
means it's gonna
triangles.
Come up unusually frequently.
Exactly, which is the only kind of problem we'll be doing.
But it only occurs here. So if I were to give you, let's say, angle A is 30 degrees, right? Let's say angle B is 25 degrees, right? And then I say,
Well, C is really.
A is 12, right? Let's say I was given those pieces right there. From there, that can only form one triangle. There's only one triangle that can be formed from those because I know what the third angle is right away. And then I can solve for the opposite sides as easy. It's this little piece where I'm given a angle, its opposite side, but instead of the other angle, I'm given a third side. And then that's where the difficulty comes in, because if I do this,
Yeah, they just should not,
Yeah.
they should just stop.
Right, sorry.
Exactly.
But you can still figure out the triangle from that information. It's
yeah.
just- Okay.
Or you
There
figure out
might
that
be
there you
two.
don't have a
And
triangle.
then you have to
Right.
solve for both.
Or there might not be any.
But the instant they give you two, oh, never mind. I'm gonna answer my question.
Okay.
Are there
This one,
ambiguous,
let's go with this
like,
one.
Real triangles there? Yes, real triangles are in a superposition. Right? If you look at them
So
different.
that
it's
is
the same.
because it's
That looks bad.
shorter than B,
Really?
but it's longer.
What?
Gotcha, okay, so let's see.
No. Who
Makes
what
sense
and
to
where?
me.
How?
How can
I
A,
think he's
if it's
gonna finish
8,
it.
look like
I
that?
think he's going
Uh-huh.
to draw more.
If B is 6,
No.
Let's see, B6, oh, 8 is A. A is
exactly.
8, that means it goes all
And
the
A
way
is bigger
down
than 6,
here,
but
right?
Exactly.
The line A is obviously not
Nice.
bigger than B.
Probably because he was planning on. No, clearly drawing the issue. It's all.
No.
Okay.
He wasn't planning on it.
I was not planning on it at all. So how about this, if we swing it this way, do we ever solve the
Oh,
triangle?
if it's longer, there's only one triangle.
Yeah, there's my way out here.
Yes!
If I swing it,
Because it would literally just overlap the other one.
So it's
if I
almost
swing it
equal.
this way, do I still have a 30-degree angle here?
So you can't,
No, but that is a triangle.
Yeah.
So
wait, yeah, so.
Not this triangle, not with the 30-degree
Wait,
angle.
so you
Oh.
it that way, but then extended the dotted line, why can't you extend the dotted line that way, but you can
Ah,
extend the dotted line?
Because it ruins this angle now.
Oh,
'Cause we're
right,
just talking
yep,
about it.
yep, that makes sense.
So in this case, yes, finally, only one solution for a triangle. All right, this is gonna be case number 4 for us. Okay, what's the conditions? Overall conditions are, you got a acute angle still, but then the A value, forget comparing it to H, we're way beyond that. It's the fact that the A value is actually bigger than the B value. In this case, one triangle, it extends all the way out to here. Whew, okay, 2 more cases here. There we go.
As fast as we've moved through, so there's problems in a long time.
Next one,
Oh.
This is number 5, right?
number
Yes.
5, case 5.
Want to make sure I'm numbering. Ooh,
Might be problematic.
Mhm.
I see nothing wrong.
I looked at that and I'm like, that's not.
All right, let's go with it here. So notice I don't compare anything to H anymore. No reason for it. I have something that's an obtuse angle now. I have 130 degrees. My opposite side is 4 units. Then my adjacent side is 6 units. Do I even have a triangle at this point? No way. This will never reach the other side. Again, no solution. It's case 5 and sad for the triangle. It didn't happen. Okay, so then what do I need to get to the other side? Only condition is
Wait, so why do we have to get to the other side if there's no solution?
if the only condition for obtuse angles is this guy had to be more than 6, right? If this guy's more than 6, I at least get to the other side. So last case, all yours, this one.
This is it.
Okay, I thought you were.
I was like,
Sorry.
I thought we were done.
Oh, yeah, in this case,
Oh,
it's 6.
what is it? A is greater than, gotcha.
A is greater than B, it's 8 now. Obtuse angle on my hands, yep. And the cool thing is, well, the good thing is, where obtuse angles, we can't get 2 solutions, not possible.
Yeah.
Right, we just need to get to the other side. So in this case, to draw it out, we just need to get this guy all the way to here, and we have ourselves then just one triangle. So one solution only.
See, just extending it does work.
One solution. This is case
You heard me.
number 6.
So looking at the pattern, if there were a hypothetical case 7, would it have 2 solutions?
No. Why would you think
Just
that?
the pattern that the cases have been in. No solution,
Uh-huh.
one
Do you
solution,
think that's a
2,
pattern,
no
Georgia?
1. So then there's 2.
Mathematics.
Sure, yeah. I mean, pattern.
You think here we are making this up as we go, Georgia?
Math has so many patterns. Let's see. This plus this.
You know,
Therefore, this makes this.
It's not from pattern.
It's a pattern.
Wait, what?
That's
3
totally how
times
math.
3 equals 6?
Yeah.
He's saying that that's why.
I got you.
Oh, I was like.
Wait, my entire life has been a lie.
He's saying essentially that nothing is real.
But if you do 2 squared and then you do, oh wait, no, that's still 9, never mind.
Georgia,
Okay.
I thought you were just giving him straight sass. I didn't realize you were being sarcastic. I was like, oh my gosh, Georgia. Phenomenal.
I don't get it.
All right, let's go with it here. Let's put some numbers to these cases here. So example 1, I kind of gave you the answer already-ish, but let's try to solve it here. So question, first of all, is even before you get there. So if you're in 7.1, you would not have this case in 7.1. In 7.2, you might just run around this case where you have an angle, opposite side, and then you have a connected side. So angle, opposite side, and an adjacent side. So all yours. Let's leave. Try to draw it out first. Think about the possibilities of it, and let's compute. Let's see if we get to. So I got a triangle in my hands. Not sure if I'm going to form a triangle. So let's see, I'm going to just kind of do a generic triangle first, like this, and see if it makes sense. I got 40 here on this side. I got A, B, C. I got 40 here. I have a 14 centimeters here. I have 62 centimeters here.
A less than 90 degrees. Side
Okay.
A,
A less than 9 degrees.
yeah.
Side, so then we can compare. These two are easy to compare to each other, right?
Oh, and A is less than B, so it's.
A is less than
case
B.
5, no solution.
So let's see, possibility is.
No, but it's not case 5, case A.
A is greater.
What?
So I think I have this, I have a possibility of
Oh,
case
oh,
1,
right.
possibly. It could be a case 2 where I have 14 is just enough to reach to the other side, right? Or it could be case 3 where it's less than 62 and it forms 2 triangles. Are we good? Logically speaking, are we good there for those? What we do have to test. What do we got to test to see if that's true? We got to do an H test over here. We got to see what's the minimum required to get to the other side. It is B multiplied by sine A. Let's see, minimum required. Whatever that guy is going to be. So need a triangle. Sorry, need a calculator.
Yeah, 39.85.
So figure.
I got 8.9.
What did I do wrong?
So, so make sure you guys are in degree mode on your
I
calculator.
got
Yeah.
8.9.
You ready?
No, I'm in degree.
Which mode are we supposed to be?
You did
reading about?
62 sine.
Degree mode.
Yeah, 62 sine
It's
40.
a degree
Oh, I
angle.
did 14, never mind.
Oh, I'm really dumb. It's a degree angle, of course.
That might be the
Sorry,
problem.
Brandon, what did you guys get?
39.85.
Yeah, same.
Yeah, no,
Okay,
whether we are in degree
perfecto.
or radians is arbitrary. We just all have to be the same one.
Yeah, but
Well, if
also
we're
40
using
degrees,
degrees.
the angle is 40 degrees.
You know, it doesn't matter.
It's not 40 radians.
It might be.
You,
No,
no.
it's not.
Yeah, it might be.
In math, do we really know anything?
Yeah.
So then it would be case
It's
1.
ambiguous.
There you go.
Yeah,
Yeah.
the ambiguous case, we don't actually know anything
So
about.
this would be case
Degrees and
1
radians
Case
are entirely
one.
arbitrary.
because,
That's the words to live by.
because,
We should become like a British instructor.
side A is less than side B.
Side A is less than side B, but more importantly is that side A is less than H.
So to find H, you always
So you-
do
Oh,
B
the
sine
14
A.
is less than 8.
It's always the angle that you're given and its adjacent side.
Oh.
So-
right.
So what I'm doing, because this is kind of tough to sort of see it here, I am using angle A consistently. Eventually, you guys ready for this? Eventually, you might get an angle B, little c, and little b. Is that still the same problem?
Yes.
Yeah, it's an angle, its opposite side, and then an adjacent side. Okay, are we good with case 1? Answer to this guy is no solution.
So how do we write that, like the results of that, because the problem says, and use the results to explain why the triangle has the given number of
So, no,
solutions?
And
It's
slash
case
A.
number 1, no solution because A is less than H. Is that what you said?
So in this case here,
Case 1, no solution.
You can't just put N slash A.
A is less than, hey, 90 degrees. I know, there's my conditions here. And A is less than H. That's the answer for it
Oh,
in math speak.
So that's what we did for the answer.
Mhm. So answer is no solution. Reason for it is because this condition is what was met.
Nice if every example starts with just like the answer right up on the top.
Yeah.
All the time.
Yeah.
Yeah. Especially test problems.
Yeah.
I love that.
You should start implementing that. I feel like it'd be really helpful.
Okay, we're good. Let's jam. Next one here. Try this one. And I somehow I think it's going to be one solution.
Are you sure? That doesn't sound right.
The directions are the same for each of these. right?
Oh, we
Uh-huh.
didn't solve for B on the last one. Was that important?
For this one?
Yeah.
We could not solve for B.
Okay. Oh, right.
No, you. Here's what
Cool, let's try it here. So generic triangle on my hands. 30 degrees, that's 6, that's 12. And then again, the possibility is, could be a case 1, case 2, and case 3. Are we good? And so the testing of it is, you know that A is less than 90 degrees. So the test is with H. We want to know what H is compared to this guy. Let's see, 12, sine of 30 degrees. I'd go with 6, perfect. Okay, so instead of drawing it as a generic triangle, how about draw it a little bit more to scale?
So in the, or like when we do this, whether it's homework or test, do we have to draw that triangle, or can we just like start with the first triangle and then put like case whatever?
You can tabulate this already real quick here, as long as you know it's the ambiguous case.
Yeah.
Once you have that, then you know exactly what you're going to draw.
So you do have to draw the second triangle?
This one here, yeah, this one you probably want to draw. You want to draw this one because then it gives you the understanding of what you're going to solve for. Okay, this guy's ABC. Solve for B.
How do you know it's a right angle? Because
So here's your conditions here. Again, A is less than 90 degrees and H is equal to A, or A is equal to H.
oh,
And that is going to be case number 2 for us. All right, what is B?
90 degrees?
90 degrees is A-okay by me. Let's do this, let's see. We know it's 90 degrees based upon the values given, right? Let's do this real quick here. Let's solve it by using the law of sines real quickly here. So let's see if your calculator would solve for it here. Sine of 30 degrees over 6 is equal to sine of B over 12. We're going to multiply both sides by 12. And are you guys okay with 2 sine 30 degrees being equal to, sorry, I'm writing it super small here. 2 sine of 30 degrees is equal to sine of B. So therefore, let's see, sine of 30 degrees. That'd be a 1, is that right? Half of 2. And then take sine inverse of 1. What do you get for B? Hey, all right. Your calculator does it well. So 90 degrees gets you the B value. Are we good?
can't totally see
See
what
all that
happens
stuff.
after sine of 30 over 6 equals sine.
Sure. I'm trying to find where my little cursor is at. Okay. There it is. Multiplying by 12 on both sides. And then 12 and 6 were reduced down to 2. And sine of 30 degrees is 1/2. We've been working with that for a little while. So half of 2 would be a 1. And then plug in sine inverse of 1 into your calculator and see what happens. In fact, let's do this here. Go back to this one right here and punch this into your law of sines. So sine of 40 degrees over 14 is equal to sine of B over 62. And you punch that in, trying to solve for angle B. So your calculator does help out in these two cases. Let's see, multiply by 62. Or 14, 62 and 14. You can just punch all this into your calculator, right? 62 times sine of 40 degrees divided by 14. What do you get? 2.84. Sine inverse of 2.84.
Does not exist.
And broke the calculator. All right. Okay, we're good. So for the no solution, when you start plugging it in the calculator, you'll find out that's a problem. For this one, you'll plug it into your calculator and you'll be surprised by, hey, that's cool, it's 90 degrees. That's awesome. Good. And then the fun one begins. Let's see, we got a triangle, it's 20 degrees here. This guy's 12, this guy's 6. Let's see, should we compare it to H, I guess, right? So it would be the opposite side, or the adjacent side, sorry, multiplied by the sine of the angle. What is H? What do you need to get to the other side?
6 times sine of 20.
Ooh, I think it's 12 times sine of 20.
Oops.
Yeah. 4.1.
Okay, that's cool. Okay, 4.1 is what I need. I have a 6 on my hands. In this case, I have 2 different triangles. I have a triangle that goes like this. There's my 6. I have another triangle. Oh, this is too far. I have another triangle that's going to go like this. Notice the 20 is still here. Notice the 12 is still here and the 6. All conditions are met.
Wait, so you still have the first triangle, but you also have another one?
Got this one and this one this time. That's no fun. I got to solve for both of them. Okay, so let's see. Let's do the law of sines. Let's see what happens here. So sine of A over little a, sine of B over little b gives us sine of 20 degrees over 6. That's easy. Sine of B over 12. We multiply this guy through. And we get 2 sine of 20, whatever that is. What is 2 sine of 20 about?
Wait, so this is for the first one, right?
I don't know. I'm going to see what the law of sines gives me.
Yeah.
0.6-ish, right? Okay, then let's do sine inverse to gives us angle B, sine inverse. Nearest 10th, how about that? Give me nearest 10th.
43.2.
Oh, no, what did I do?
43.2.
Oh, no, what did I do?
I got 36.7.
Oh, gotcha. Okay, so you don't want to put in 0.6. You want to put in whatever this is. I just did it for approximation. So 2 sine of 20 degrees. And you want to make sure all those digits are there. And then you want to do the sine inverse of that.
Okay, awesome.
All right. Tell me if you get 43.2. Which triangle is it, top or bottom, that I get a 43.2? Top is good. This is 43.2. That's nice. And the question is, how do I get this one now?
Wait, how do you know it's the top one again?
I got it by calculator, and it's
Yeah.
less than 90 degrees,
Oh, okay.
where this clearly is gonna be more than 90 degrees. And let's see what happens here. Notice what happens with this first one here, is we get this little line here, right? This is this little side that's swung to the other side, right? So we have this case now right here. So the question is, what is this angle right here? Because that's the same angle here. Maya says 180 minus 43.2. Anybody yes or no on that one, and why?
Yeah, it's also a triangle, so you know that angle is the same, and then use it or not be out of that.
Perfect.
Straight line, so.
Okay, isosceles triangle on this side. Everybody agreed there? So that means this guy has to be a 43.2. This one has to be the supplementary angle. And what is the supplementary angle? One 136.8. Okay, now what we're gonna do is we're gonna label this not as B. We're gonna label it as kind of like a B. We call it B prime, which is a second version of B. We're good because we have two angles. We have two triangles on our hands that we have to think about.
Sorry, can you explain again how you got the answer for that one?
So notice that if I were to drop a altitude down, now to swing this side over to the other side, like this, I have myself an isosceles triangle. So these two sides are exactly the same. Therefore, the inside is still 43.2. Therefore, the other side
Oh,
would be
you subtracted 43.2 from one.
perfect. And we're gonna call it B prime.
How do you, just with a little one?
It's like a one or almost like an apostrophe on the B. And we are done for today because we're out of time. I mean, if we had more time, I would spend the whole day doing trigonometry, but you guys have other classes.
No,
Yeah, they want us to
when you
learn
think
other
about
stuff
it, there is no time at all.
Okay, Matthias, you keep on living that way, yeah? Let's see how that works out.
Time is a
There is not one. Oh.